Hello, my name is Sheyi Fabiyi. I've come for another series, another edition of our GIS lecture series. This is actually in a response to some of our subscribers have asked us to do something on NDVI. We are going to this short video to show us on how we can perform normalized different vegetation index using IDRISI software. Actually, the use of NDVI or other versions of NDVI, vegetation indices, there's a lot of usefulness. We are just going to briefly, because it's a short video, we cannot exhaust all the things we can do with the NDVI. But actually, the purpose of using NDVI, especially when we are dealing with low or medium resolution images, is that it help us to look at the level of greenness, the quantity of vegetation greenness, or the health of the vegetation. It gives us the understanding to look at the density of the vegetation, the density of the chlorophyll of the vegetation, so that we'll be able to know how nitrogen rich the vegetation is. And you can use that one to compare the vegetation in one area to vegetation in another area. You can also use it to compare the vegetation in the past with the current situation of vegetation. We can actually look at it, use it to check the level of deforestation or the level of vegetation degradation that is taking place, because NDVI is a measure of greenness of the vegetation. So it is computed. Usually, NDVI actually started with Landsat data, and they have used the near infrared, because the vegetation, the chlorophyll component of the vegetation is really brought into the fore with the red band and the near infrared band of the electromagnetic spectrum. So when we look at the near infrared band and the red band, where that can capture effectively and efficiently the vegetal cover, then we can now ratio it. It's part of the image ratioing analysis. We are still going to consider image ratioing systems or image referencing systems in our subsequent edition of the GIS lecture. So, Landsat has 7 bands especially for the Landsat 4, Landsat to Landsat 7, but the Landsat 8 actually has 8 to 12 bands. So, in Landsat 4 to 7, NDVI is computed as near infrared minus red divided by near infrared plus red. Is an equation in which we minus band 3 from band 4, because the band 4 of the Landsat 4 to 7 is near infrared and band 3 is red band. So we are going to subtract band 3 from band 4, and we are also going to add band 4 plus band 3, and we are going to divide it. That will give us the NDVI. In the Landsat 8, it is band 5 minus band 4 divided by band 5 plus band 4. So we also have different versions of vegetation indices. We have the image ratioing, we have the ratio vegetation index, we have enhanced vegetation index, we have transformed vegetation index, we even have water vegetation indices. We have different form, but we are just going to look at today. We are just going to look at the normalized vegetation index, which we have shown the computation in our this. So we are going to use IDRISI Terasat to check how we can check the thing. Let's look at the band 4 and band 3 and band 4 of the images now. We are still going to use our sample data. This Sarah 3 is band 3 of Landsat for the study area. This is band 3 of Landsat. Let's open band 4. This is Syria 4. And you can see band 4 of Landsat. So if you want to get the NDVI of these two bands, which is the image of the same area but with different, look at it from different windows of the electromagnetic spectrum. So we want to see how we can combine, we can do the normalized difference vegetation index and get uh, the the greenness of the image. So how we do it, we go to the IDRISI image processing module, and then we go to transformation submenu, and then we have a VEG index. When you go to VEG index, you have different types. We have the ratio, we have RVI, EVI, and all sorts of other water differential vegetation index. They have different usage, they have different applications. But we are going to look at NDVI today. So the red band is band 3. So we are going to pick Syria 3 as the red band, and the near infrared band is band 4. So the computation is done by just know the relationship is band 4 minus band 3 divided by band 4 plus band 3. So you can now give it a name. We call it a VEG index, vegetation index Syria, for Syria. And there you go. That is the vegetation index using Syria 3 and Syria 4. You can see that the vegetation component is brought to the fore. You can see the richness of the vegetation index. So if you now see, if you look at the image of another period, if this one is 2005, and then we have the image of 2015, we can be able to estimate the difference in these two images. And that is how you can easily get a vegetation index, and it is very, very simple. In other software type, it also gives us different different approaches to use it, especially if you are using EDAS imaging. It also has its own computation, how you supply the input. In this one, it has taken away that computation complexity away from the user. So you just select your band 3 and you select your band 4, and then you got your image. I think you understand the vegetation index. It is very useful when we are trying to look at the effect of climate change, or we are trying to look at the deforestation, or want to look at the vegetation degradation. How nitrogen rich is the vegetation? What the level of chlorophyll of the vegetation? You can see that this image, you can use it to look at the component of the greenness of the vegetation. Thank you for watching.